Unit 3, Lesson 1, Measurement. This is a review and a preview of what we're going to be learning this unit. This lesson looks at two topics which will occur throughout the unit, rounding and substitution. Rounding. Often when we do a calculation, the answer is a non-terminating decimal or contains a large amount of digits. In such cases, we are often asked to round off the answer to a particular degree of accuracy. Rounding also aids us in determining whether or not the answer is reasonable. If you look at the right, you'll notice that these are the categories. We have the tenths, hundredths, and thousandths to the right of the decimal. And then we have our thousandths, hundredths, tens, and ones column. So for the first one here, I'm just going to go over a couple examples. So it says here, round to the nearest 1 or round to the nearest whole number. So if we're rounding to the nearest 1, we're going to look at this digit, and that will determine if we are going to round up or round or keep it at the same digit. In this case, because it is 5 or less, we are rounding down. Please look at this example. In this case, the 7 is higher than 5, so we are going to round up to 3 instead of the previous example where we kept it at 2. I'm going to let you look at these examples, and we're going to just as a review, and we're going to continue on to the table where I would like you, please, to try the following examples. So the answers are as follows. This number rounded to the nearest 1 would be 539. To the nearest 10, it would be 540. To the nearest 100, it would be 500. To the nearest 10th, we would have 538.6. To the nearest 100th, we would have 538.60. Note that you don't have to include the 0. To the first decimal place, we would have 538.6. And to the second decimal place, that is the same as the 100th. It is 538.60. The second example, the answers are as follows. Please try the example first before you check your answers. So now that we're comfortable with rounding and what the names of each number value place is, we're going to continue. In this course, we do not use a graphing calculator, so please continue to the section that states rounding in scientific notation. So as learned in Unit 2, some numbers are so large or so small they are written in scientific notation. Recall that when you are writing a number in scientific notation, the first part of your statement has to be in between 1 and 10, as indicated here. And then you're going to multiply it by base 10 to an exponent. The exponent n is an integer, and that is determined by how many spaces, place values, you had to move to the left or to the right. So please try A. the answer to A, we would put the decimal place in between the 7 and the 5, so it'd be 7.53. And our exponent here times 10 to the, we're going to see how many decimal spaces we moved from the original spot right here to the decimal place in between the 7 and the 5. We're moving 1, 2, 3, 4, 5, 6, and 7. So this will be 7. I know it is a positive 7 because this number that we started off is a larger number. Now take a look at B. Please try it yourself first. And now check with the answer. So we're going to have the first number be in between 1 and 10. So it's 3.892 times 10 to the. So we're starting off right here. This decimal is the starting point. We're moving that decimal place over 1, 2, 3, 4, and 5 spaces. So please put the 5 there, but note that it is a small number, a number less than 1, so we make that a -5. In each case, perform the calculation and give the answer in scientific notation to one decimal place. So please try the following question. The first question, you're simply going to multiply the two numbers together. And we should get, using your calculator, 22.3155. We're going to multiply that by the base of 10. And what we're going to do with those exponents is add them together. So 2 plus -6 would be -4. You'll now note that we can't leave this answer like this, as it is not in scientific notation. We have to move the decimal place from this place right here to right there, because our first number has to be in between 1 and 10. So our first part is now going to be 2.23155. And because we moved that decimal place 1 to the left, we're going to change this -4 to a -3. Now, why we do that is, if you see in the original question, we're moving 4 spaces to the left to appreciate this -4. Okay, to make that a smaller number. If we move the decimal place over 1 to the left, that's allowing us to move 1 decimal place less, and hence the 10 to the -3. Let's try B. So in B, we are also going to divide our two numbers using our calculator. And in this case, it is 1.6679, etc., etc. So I will round it to 3 decimal places for this one, 1.668. And what I'm going to do with the exponents is I'm going to subtract them. So in this case, I would have -2 subtract -10. The integer rules state that if you have a subtraction, you're going to change it to an addition and change the next integer to its opposite sign. So we have -2 plus +10, which would be +8. So this would be 10 to the +8. You'll note in this case, it is in scientific notation. Hence, this will be my final answer. And my last example right here. Writing this in scientific notation. So all I would do is I would multiply those two numbers together using my calculator. And using my calculator, I would get an answer of 2,744.22335. I'll just keep one decimal place. And now I need to change that into scientific notation. Sorry. So for this question, I'm going to have my first part in between 1 and 10, so 2.7442. And I'm going to put that times 10 to the, well, I'm moving that decimal place from here. I'm moving it 1, 2, 3 spaces, so I'm putting it to 10 times 10 to the third power. Next up is substitution in algebraic expressions. When replacing variables with numbers, always use brackets. So please always show your work when you're doing questions like such. In this question, it asks you to please substitute x to be 2 and y to be -3. So check it out. What I will do is wherever there's a y, I will put a bracket there, and I'm going to put the y value in there. Y is -3. It states that I need to square that. The value for x is 2, so I'm putting that right here. And then I'll continue with -3. Now I have a question where I can solve it. So -3 squared, that means -3 times -3 is +9, minus 7 times 2 is 14, and I'm just going to subtract that 3. 9 minus 14 minus 3 will give us -8. Please take a look at B. Same situation. Wherever there is an x, we put a 2. So we have 9 times x, which is 2, and I'm going to square that. I'm going to subtract from that y, which is -3. And I'm going to add to that y cubed. So -3 all to the power 3. So for this question, just like we learned in BEDMAS, we are going to do the exponents first. So there is no brackets. There's no operations in brackets. There's some brackets here, but these brackets are just to separate the negative signs. So we're going to do this first. 2 times 2 is 4, so I'll just bring that 9 down. This is the 4. Bringing that down, and I'm going to also do the -3 cubed. So -3 times -3 times -3 is -27. Now we're going to do the multiplication right here. So we will multiply these two numbers together, giving us 36. And I'm going to go ahead and do the A and the S. So in this case, we're doing this next. So remember, when you have a subtraction in integers, we're going to change this to an addition and change the next integer to its opposite. So I'm actually going to add 3 to this. And finally, add -27. So let's wrap this up. We're going to take 36 and we're going to add 3 to that, giving us 39. And 39 plus -27. So 39 plus -27 will give us +12. Final answer. All right. Substitution using a graphic calculator. We are going to skip that as we are not using a graphing calculator in this course. Substitution using formulas. So in each case, in each of the following, substitute the given value. So first you need to place the number into the equation, and then the second step is to calculate the value for the variable indicated to the nearest tenth. So don't forget that the tenth is basically the first decimal place. So in this case, we would round it. This 2 will make that 4 stay the same. So this rounded would be 14.4. All right. So in this case, it says V is equal to 12. We're going to calculate T. So I'm going to write this equation out. Wherever there's a v, I'm going to plug in my value that they gave us, 12. This is an algebraic expression. You can do this two ways. You could ask yourself, 12 times what gives me 60? And you should say that answer is 5. T is equal to 5. Or what you can do is you can do the opposite on both sides. So if you have 12 times t, the opposite of 12 multiplying itself by t is dividing by t. And remember, an equation, whatever you do to the one side of the equation, you have to do to the other, okay? So check it out. 12 divided by 12 is 1, so you've successfully isolated the t, and 60 divided by 12 is 5. Your answer is t is equal to 5. Either way is fine. Looking at B. So in this case, they say S is equal to 100, and we're calculating R. So where S is, I'm going to put 100, and this equals to 4 pi R. Now, if you could recall in your previous math classes, pi is equal to 3.14. So what we're going to do right now is I'm actually going to substitute that also into my equation. So this is 4, this is 3.14, and we're looking for R. So ladies and gentlemen, we're going to divide both sides here by whatever we're trying to get rid of, and that is 4 times 3.14. So I'm going to divide both sides by the product of 4 times 3.14. 4 times 3.14 divided by 4 times 3.14 is 1. So we're left with R on this side. And then 100 divided by 4 pi, that equals to 8. So R is equal to 8. And I'm assuming in this case they're talking about the radius. C. In C, they're asking us to calculate R, and they're giving us V. V stands for volume. So let's put the number 95 where V is, and I'm going to ask you to rewrite 4/3 pi R cubed. So in this case, you'll note that this is what we want to get rid of first. So the way to divide by this value is actually interesting. We're going to multiply. So, okay, let's do this in 2 steps. The first step is we need to get rid of this 4/3. And to do that, we actually multiply by 3/4. Let's see if that makes sense. 3/4 times 4/3, that equals to 1. So we've successfully gotten rid of that. So far we have 3 times 95 divide by 4. Please don't mistake that by 3.95. It's 3 times 95 divided by 4. And that equals to pi R cubed. Now our next step here is we're going to divide both sides by pi. So check it out. We're going to divide this side by pi, and I'm just going to write a pi in right here. We're going to divide that side by pi. We've now gotten rid of this because pi divided by pi is 1. We're left with R cubed is equal to 3 times 95 all over pi 4, or 4 pi. And to find out what R is, all we do is we take the cube root of the left side and the cube root of the right side. So in this case, R is equal to, and you solve this in your calculator, 2.8. Example number 8. In each of the following, you are asked to solve for the variable indicated, then substitute the given value and answer to the nearest tenth, where necessary. So in the first situation here, it asks us to solve for R, and then calculate the value of R when s is equal to 75. So first step is solving for r. So let's rewrite this equation right here. So to solve for r, we are going to divide by pi to get rid of this pi. But we are also going to multiply by 4 because 4 over 4 is 1. So you'll notice that I've multiplied the right side of the equation by its reciprocal. The reciprocal is the flip of a fraction. Remember, whatever you do to one side of the equation, you have to do to the other. So in this case, let's simplify this. We have 4s divided by pi is equal to r. Our second step is to solve for r when s is equal to 75. So all I'm going to do is where s is, I'm going to place 75, the value for s there. Four times 75 divided by 3.14 equals to, so r is equal to 95.5. We round it to one decimal place. B. If a is equal to pi r squared, solve for r, then calculate the value of r when a is equal to 72. So first steps first, let's isolate r, and then what we're going to do is we're going to substitute value for a and actually find out what r is equal to. So let's once again rewrite the formula of area of a circle. A is equal to pi r squared. Step 1 is we're going to divide both sides by pi. Note that on the right side that equals to 1, so we've successfully gotten rid of that. We now have a over pi, or a divided by pi is equal to r squared. Next step is we're going to take the square root of both sides. So r is equal to the square root of a over, or divide by pi. So in this case, what we're going to do is we're going to substitute our value in here. A is equal to 72. We're going to divide that by pi, or 3.14. When you do this on your calculator, you should get 4.8. C. If v is equal to 1/3 pi r squared h, solve for h, and then calculate the value of h when v is equal to 20. So here we're solving for h. Oh, and r is equal to 9. So we're substituting two values in here. So first steps first, let's rewrite the formula. V is equal to 1/3 pi r squared h. So once again, we're solving for h. So first step is, let's get rid of this 1 over 3. We do that by multiplying by its reciprocal, 3 over 1. Remember, whatever we do to one side, do it to the other, please. So we now will have something that looks like this. 3v is equal to pi r squared h. We are now going to solve for h, so we need to get rid of our pi r squared. So just as before, we're going to divide both sides by pi r squared. Look what happens. On the right side, that will equal to 1, and we have a equation 3v divided by pi r squared, that equals to h. Now they ask you to substitute two values. The first one is the value for v, and the second one is the value for r. So let's plug in the value for v, which is 20, and the value for r, which is 9. Now once calculated on your calculator, you should get a value of h being 0.2. And that concludes our first lesson in our measurement series. Please let me know if I'm going too fast, if you're at home listening to this. All right.